let me give you a tiny example. Okay, so like let's say, I don't know, let me make something up. What's a number? So for example, 49, I could rewrite that as 7 squared. So I'm going to give you these numbers up at the top and just ask you, could you think about that for a second? And maybe in as many ways as possible, because some of these have multiple things you can do. How could I rewrite that number as something to a power? So like if I give you 81, so if I give you 81, how could I rewrite that as something to a power? 9 squared. There's actually another one. Does anybody know the other one? 3 to the 4th. All right, we're just giving ourselves options here. It's going to make more sense when we start doing these problems. What about 64? Can you think of a way to write 64 as something to a power? Yeah, what do you think? 8 squared. Can anybody think of another one? There's actually 3. 4 cubed. Does anybody know the third one? Yes, 2 to the 6. So 3 different options there. Okay, now, if I have a fraction, this is a little tricky. I have 1/2. Could you rewrite that for me as something with an exponent? Yes. Okay, so fractions, remember they're negative exponents. So 2 to the negative 1. Now, typically I would tell you like a negative exponent's not simplified, but it's actually going to help you out in some of the problems today. So 1/2 is 1 over 2 to the 1st. Basically, you could move it and unlose the negative, if that makes sense. So this would become 2 to the negative 1 as a way to rewrite that as a base with an exponent. So if you've got a fraction, you're going to have a negative exponent. What about how could we rewrite 1 over 125 with a base with an exponent? There you go, 5 to the negative 3. There you go. And feel free, look at that little piece of paper if that helps you in any way. What about 1 over 27? How could I rewrite that as some base to a power? Yeah. There you go, 3 to the negative 3. Anybody have any questions? Because we're going to use that in what we're going to do at the bottom of this. Okay, so we're going to just do a little basic introduction to some exponential equations today. I'm going to remind you guys just for a couple of these of some exponent properties before I start. But an exponential equation, all of these are exponential equations. You've got a variable somewhere in an exponent. So some of these have multiple exponents and the variables in multiple places, but the only requirement for an exponential equation is you have a variable somewhere in an exponent. Okay, before I do any of these, I just want to ask you a little question here. If I did, if I multiplied like bases, so like let's say I had x squared times, I don't know, x to the 7th. How would you simplify those exponents? Like what would you do with the 2 and the 7? Add them. Okay, so you guys remember that. So you add exponents on like bases. And I don't know why, but for some reason, if my base is a number, that throws people off. Okay, so each one of the little pieces of this equation has a base, like where I just had the x, that has a base of 3. Okay, if that's the case, and you could do this all in one step if you wanted to, but I'm going to do 2 steps. This is 3 to the 4x. On the other side, I'm multiplying like bases, so that base would stay 3. We would not change that to 9. That's the most common thing people actually accidentally do, so keep the base the same. But I would actually add the exponents together there, so 6x, and to that I would add the other exponent, which is the 5x minus 14. So I'm just applying exponent properties. Okay, now here's the deal. If both of these have base 3, right, they're both 3 to a power, that forces these exponents to be equal to each other. So you can just, don't worry about the 3, as long as it's the same base. Really, the equation I'm going to solve here is 4x, and then the 6x plus 5x minus 14. Now, of course, you can 6 and 5x will give you 11x. I could have simplified that, but I'm just trying to show you where it comes from. So you try to get the bases to be exactly the same on either side, and then you could just set the exponents equal to each other. Now, all you got to do to solve this, I'm just going to move the 11x real quick to subtract that to the other side. So I'd get all my variables on the left there. So I get negative 7x, and then that's equal to negative 14. All we have to do is divide by negative 7, And the negatives are going to cancel out there, so x is just going to end up being 2. Anybody have a question at the moment? If I don't have like bases, what I want to try to do is create like bases. So that's what's going to happen on this question here. So I have 5 to the 2x minus 4. Can you guys think of a way you could maybe rewrite 25 so it was 5 to a power? 5 squared. All right, so 25. I'm not doing anything. I'm just manipulating this for our purposes. So we've got 25, which I can write. It's the same thing as 5 squared. If I then match up those bases like we just did there, then that forces these exponents to be equal to each other. So all you have to do for your equation there, we're just going to take 2x minus 4, set it equal to the exponent on the other side, and then we're just going to solve. Just 2 steps here. I'm going to add 4, so we would end up with 2x is equal to 6, and then we just divide by 2, and we're good. So x would end up being 3 here. Okay, now, you may have any questions so far. Okay, now I'm going to remind you of another exponent property before I do the next question. Okay, so let's say I had, I don't know, let's say I had x squared, and then I took that to the 5th power. What would you do with the exponents in that scenario? You had a power to another power. Please remember, you multiply. So this would be x to the 10th. Okay, that's going to come into play in these questions that we have down here at the bottom. So this was just a little reminder of the exponent property. Okay, now I want to try to write so each side of the equation uses the same base. And again, this might be where that little yellow card might be helpful to you. You are not going to rewrite 8, or you're not going to rewrite 32 as 8 to a power. And I'm not going to rewrite 8 as 32 of some kind to a power. So, can you guys think of a number that both 32 and 8 would have in common that we could use as a base for both? Like if you were thinking about 2. Okay, good. Now, if you guys, I don't have a little yellow paper up here, but if you look at the row with the 2's, you'll see 8 and you'll see 32 on that row. So what I'm going to do, we're going to rewrite this real quick. 32 is 2 to the 5th, right? Now, I still have this exponent, this x minus 1, and then 8 is 2 to the 3rd. So my whole goal there is to try and make those have the same base, the 32 and the 8, so I rewrote them both as a base of 2. Okay, now this is why I reviewed that little tiny exponent property with you. When you take a power to a power, and it's a little weird here because it's an expression, but you're going to multiply these exponents together. So I rewrite this as 2 to the 5th. I have to take 5 times that x minus 1. And then on this side where I rewrote 8 as 2 to the 3rd, I got to now take 3 times this 2x plus 3. Otherwise, it's just a little more complicated because we're going to have to use a distributive property. But both of my bases are 2 there, so I can just set those exponents equal. So all I want to recommend that you do, like I have 2 to the 5th, take 5, and then put that exponent that you had in parentheses so you don't forget to distribute. The other side would be 3 to the power of 2x plus 3, so we would multiply these guys together. So it's a little more complicated because we're going to have to do a couple extra steps. But it's not too bad. We're just going to do a little distributive property. So I'm going to get 5x minus 5 when I take 5 times the x minus 1. And I'm going to do 3 times 2x plus 3. So it's going to be 6x plus 9. Now, completely up to you. If it's me, I like to keep my variable positive if I can. So I would probably subtract 5x there from both sides. So I'd get negative 5. This would just actually give me 1x plus 9. The only other thing I got to do there real quick is move the 9. It's positive, so I'd have to subtract it to move it to the other side. And then my answer is going to end up being, excuse me, negative 14. Anybody have any questions? Okay, now I got one more super complicated, has a bunch of properties here. So I don't have the same base. I've got a 1/27th, I've got a 3, and I've got a 9. So I want to look at those 3 bases. What number would all of those have in common that I could rewrite each one of those as something to a power? Okay, so what would you do to rewrite the 1/27? Perfect. Okay. Now, we could just keep the 3 by itself, right? It's already the same base. What would you do to the 9? 3 squared. Good deal. Okay, so really we just have to change 2 of them because one of them did have a base of 3. Okay, now you got several things going on here. So on either side, all these are 3, so we're good. 2 things. We're going to distribute on 2 of these because we got a power to a power. And on this right side here, you are multiplying like bases, this 3 and this 3 squared here. You got to add between them. So I'm just focusing on the exponent. So on the left side, you'd have negative 3 times your exponent, which is negative 2x minus 10. On the right side, since I'm multiplying like bases, I'm going to add these exponents together. So the exponent on that first term was 4x plus 12. And I'm going to add to that. Now the other one, I had to rewrite 9 as 3 squared. So I do have a power to a power here. So we have 2 times 2x plus 5. So this is a little bit of a challenging equation here. So we've got 6x plus 30. Those negatives times the negatives going to cancel out. You just got the 4x plus 12, nothing to change there. If you distribute the 2 to that last term, that exponent, you're going to get 4x plus 10. And then if you just combine some like terms there, 4x and 4x will give you 8x on that right side, and 12 and 10 will give you 22. Now from there, it's completely up to you. Like I told you guys in that last question, I like to try to keep my variable positive if I can. So if it was me, I would subtract 6x from both sides. That'd give me 30 equals 2x plus 22. Then I'm just going to move the 22. It's positive, so I got to subtract it to cancel it out here. 30 minus 22 is going to give you 8. And then all I got to do to get x alone here is divide by 2. So my answer should end up being 4. No, why don't we put the basis? Because you're just trying to find the value of the variable. Like if I plugged in 4 to that original problem for each of those x's, it would make both sides the same. Does that make so? If you can make the bases all the same, it basically just cancels them all out, and you don't have to worry about it. That's a really good question. But it would be like 3 that is getting plugged into each of the exponents for x there. Really good question. Anybody else have any questions? Okay. Please forgive. I'm going to introduce logarithms to you guys today just a little bit. We're just going to practice with some notation. But I totally, I screwed up when I typed some of this up here at the top. So let me see if I can make this a little bit bigger. Okay, where I have, this says right, otherwise it doesn't make sense. There's 2 places. I just got to have you do me a favor. This should say b to the y power, and this, it says b to the x in those 2 spots. So like right here, it should be b to the y power, not the x. It's my fault. And this one should also say b to the y power, not the x. Or if you want to just, maybe I should just like cross it out. This should say b to the y, and this should say b to the y, not the x. That's my fault. I mistyped it when I put it in there. Okay, so just fix that for me real quick. And then I'm going to go back out. Now, we have been working with exponentials so far completely in our unit, and we're going to introduce logarithms today. Sorry, logarithm is the inverse of an exponential. They cancel each other out, like addition cancels out subtraction or multiplication cancels out division. So a logarithm cancels out an exponential. So at the top here, I just have these 2 things are equivalent. This says x equals b to the y. That's called an exponential form because you guys see an exponent there. The other format, this is exactly the same. These are equivalent to each other. They're just 2 different ways to write it. This would be read the log base b. The little subscript is called a base. So that says the log base b of x equals y. Those 2 things are equivalent to each other. So we're just going to go through this really quickly, and then I'm actually going to do some problems with you. So this is going to sound kind of complicated, but it's not too bad. Okay, it says the exponent y in this expression, b to the y, is the logarithm in the equation log base b of x equals y. So that's the logarithm there. They use the word log to abbreviate that. Okay, the base b, and this should say b to the y, is the same as base b in the logarithm. So the base of the exponent and the base of the log are the same. Okay, in both, this has the same rules for your exponential. B cannot be equal to 1. And b is greater than 0, that just means it's positive. So anything, when it says something is greater than 0, it's just trying to tell you it has to be a positive number. B cannot be a negative number. Okay, now, since b can't be 1, and b has to be positive, b to the y also has to be positive. So if I plug in any value for y, doesn't matter whether it's positive or negative, if I plug in any value for y, if b is positive, b to the y power has to be positive. It might be a fraction, but it's not going to be negative. Okay, since b to the y is equal to x, all right, and that has to be positive, then x, I'm just going to write x is greater than 0, which just means x has to be positive also. Okay, so the log base b of x, so whatever you're taking the log of where you see that x is only defined when x is positive. All right, now what follows from that is what I have written right after this, okay? So this just says you cannot take the log of a negative number. You also cannot take the log of 0. If you try to do it on your calculator, it'll tell you it's an error, and that's because it's not possible for that to happen. So just right under here, I just have a teeny tiny little equation. Let me show you how I would convert this real quick. This is an exponential, and it just says, does this have a solution? As a logarithm, what this would look like, it would be the log base 6 of negative 36 equals x. But let me have you guys look at the actual equation I wrote here. Can you think of a number that you could plug in 6 to this power that would make that negative 36? Can you think of like any x value, like if I put in a negative exponent, would that make it negative 36? No, this doesn't. No, it says, does this have a solution? No. Like if I do 6 squared, that's positive 36, right? If I do 6 to the negative 2, though, that's just not negative. It's 1 over 6 squared or 1 over 36. So there's no value of x that you could plug in there that would make that true. There's no way to make that negative. So if you end up with any problem like this, if you're taking a log, doesn't matter what the base is, if it's of a negative number, there's no solution there, because this does not actually have an equation. So you cannot take a log of a negative number. Like we can't take the square root of a negative number and get a real solution. This is not going to involve i's or anything like that, but you cannot take the log of a negative number. That is the main thing to remember today. Okay, now the other thing before we start doing some problems. This is just a little nitpicky. They have something called a common logarithm, and whenever you see these, like the one I just wrote, that was a base 6. So like I can have like a log base 3, or I could have like a log base 4 or something like that. We could change the bases. If you just see the word log, that's called a common logarithm, and you can assume that it has base 10. So if I just literally had the word log 6, that's equivalent to the log base 10 of 6. So if it has a base of 10, typically that's not written into the problem. So if you ever see just a log with no little subscript, then you can assume the base is 10. That's called a common logarithm. And I do have that in a couple problems. Okay, before we evaluate any logs, I'm just going to have you guys practice converting between exponential form and log form. So that's what we're going to do in these two examples here real quick. Now, each one of these, in example 3, and well, in example 2, these are all true statements. Right? Like 729 is 9 to the 3rd power. All I'm going to have you guys do here is just practice converting this. This is exponential form. We're going to convert it to a log. Okay, now, the base of your exponent, which is the 9, is going to become the base of your logarithm. So, I actually physically like to draw on this to do it. So, I'm going to take this base of 9, and we're going to swing this to the other side of the equal sign out in front of the 729. The base of my exponent becomes the base or the little subscript for the log. So to get this away from being an exponential, the 729 is going to stay where it's at. You're going to drag that 9 to the other side. When you drag that 9 to the other side, it brings the exponent of 3 down on the level with the rest of the question. So when you have an exponential, you can convert it to a log that gets rid of the exponent when you drag that to the other side of the equation. And there's nothing else to do here. This is a true statement. We're just practicing doing this. But what I wanted to show you here, if you convert between the two formats, the base of the log is the base of your exponent. Those are the same. So the base of the exponent becomes the little subscript for the log. Okay, so just to practice this, the base of my exponent here is the 1/2. So I'm just going to swing it across the equal sign, right? Leave the 1/8 right where it's at. We're going to introduce the word log because we're going to convert this to a logarithm. The base of my exponent, the 1/2, becomes the base or the little subscript for the log. The 1/8 stays where it's at. And then when you drag that 1/2 to the other side, it pulls that exponent of 3 down on the level with the rest of the question. So base of my exponent becomes the base of the log. These are equivalent statements. One's called exponential form because you have an exponent. The other one's called log form because you have a log. Excuse me. And then the last one's just kind of written in a different order. I have the base and the exponent first, but I'm going to do the same thing. I'm just going to drag it to the other side of the equal sign. So that -2 comes down right out of the exponent on the level with the rest of the question. And the base of my exponent becomes the base of my log. And then that 1/100, that's just going to be what you're taking the log of. So the base of the exponent becomes the base of the log. Now, this, because it's base 10, and only because it's base 10, this is called a common logarithm. You can just write this as -2 equals the log of 1/100. If you don't have a subscript written in there, it's assumed to be base 10. You can write the base 10 or you don't have to if you have a common logarithm. Completely up to you. Is anybody having a question? Okay, now we're going to go the other way. I'm going to give you a log. These are all true statements again. And we're going to convert it to an exponential. So we're not solving anything here. We're just working back and forth to show you the difference in the two formats. Okay, so in this case, you're going to get rid of the log. So the base of your log is going to become the base of your exponent. So I'm going to get rid of the word log. The little subscript is going to swing across this equal sign, and it's going to push that 5 up in the air into being an exponent. And so this would be 1024 is 4 to the 5th. You guys want to check that on your calculator? You could do that real quick. Do 4 to the 5th power. It should be 1024. So these are true statements. We're not solving anything. We're just showing the conversion between the two different formats. And so here, my base of my log is now the base of my exponent. So a little subscript turns into the base of your exponent. So same thing here. I'm going to get rid of the log. Just swing the little subscript. It's 1/3 here. You keep the 27 right where it's at. 1/3 is going to push that -3 up in the air into being an exponent. So the base of my log is now the base of my exponent. And that's also a true statement. If you want to do that on your calculator, do 1/3 to the -3 power, it'll be 27. Now the last one, since it just says log, just to practice this with you guys, if it just says log, you can go ahead and assume that you have a common logarithm, which is base 10. Now I personally like to write the 10 in there because it actually gives me something to swing across the equal sign. You don't have to do that, but I just like to. So I'm going to take that 10, we're going to get rid of the log by converting this to an exponential. The 1's just going to stay where it's at, and 10 is pushing that 0 up in the air. There is nothing to solve here. The statement you've got there, anything to the 0 power is 1. So base of my log, which was 10, becomes base of my exponent. 10 to the 0 power is 1. Is anybody having a question between converting the two different formats? Okay, now we're going to use that. I'm going to kind of connect that back to what we did at the beginning of today. So I'm going to have you guys evaluate these logarithms, and it's going to say do this without a calculator. Okay, so if you see evaluate, this means find a value. So like I should have a number answer here. If it's asking you to evaluate, you should have a number answer for each of these questions. Okay, here's what I would recommend. Here's my process here. I would tell you to set each one of these, pick your favorite variable. I usually just use x, but set each one of these equal to x, and then I'm going to convert to an exponential. And then we'll go from there. And it'll be more like the questions we were going to do on the front. These you got to be able to do without your calculator, but use your little yellow paper if you want to. So for each one, I'm just going to start out and I'm going to set this equal to x. And then what I'm going to do is exactly what I just did in the last question. We're just going to have another step because we're going to actually have to solve this because we don't know what x is. So I'm going to get rid of the log by converting this to an exponential. So the little subscript, my 3, base of my log is going to push that x up in the air, and it's going to become the base of my exponent. Now all you got to do is you got to tell me what would you plug in for x to make that true. Anybody know? 4. And if you're like, what the heck, where did that come from? Look at that little yellow piece of paper. 81 is 3 to the 4th power. And that's exactly what we were doing on the front. We were trying to create like bases. So here it would just be 4 and x are in the same spot, so they have to be equal to each other. It's a little bit less complicated of an equation to solve than what we were doing on the front, because there you just set them equal. As long as you got the same base, you're good. The answer I'm looking for there is 4. Okay, now, if you don't have a base, like this one just says log of 1 over 1,000, I'm going to set this equal to x, but my base is 10, and I like to write it in on my problem. So I'm going to swing that to get rid of the log. We're going to convert to an exponential. The 1 over 1,000, I'm going to leave where it's at, and that's going to have that 10 push that x up in the air, so it'd be 10 to a power. Okay, can anybody tell me, how would you like rewrite 1 over 1,000? There you go. This would be 10 to the negative 3. And so then to make that, both of them are 10, the exponents have to be equal, so negative 3 would be my answer here. Okay, so just whenever you're doing these, this says log base 5 of 25. I'm going to set it equal to x, so I can just convert it to an exponential real quick and solve it. So I'm going to scooch that x up in the air, get rid of the log. The 25 stays where it's at. Base of the log pushes that exponent up in the air, so this would be 5 to the x. You guys think what x should be there? 2. You don't have to write out a bunch of steps. If you just know, okay, that's 5 squared, be done with it. But if this helps you, 25 is 5 squared, and if they have the same base, excuse me, then those exponents I would just set equal. Okay, now the 3 at the bottom are going to be a little bit trickier. So same thing, I would tell you, let's set these equal to x, get rid of the log, we're just going to convert it to an exponential. So keep the 16 where it's at, the base of the log, the 8, is going to push that x, we're going to swing that across the equal sign and push that x up in the air. That converts it to an exponential. These are equivalent to each other. Okay, so I'm not rewriting 16 as 8 to a power, so I got to rewrite both of these numbers. What would you think of as a good base to use between 16 and 8? 2, right? Can't be 4 because 4 to a power is not going to give you 8, so we're going to use 2. All right, 16 is 2 to the 4th. Okay, now this is going to bring back what we were doing on the front. So 8 is 2 to the 3rd, but then I'm taking that to the x. It's a little easier equation than what we saw in the front, but you want to make sure power to a power, I'm going to multiply those exponents. Both of them are base 2, so we would have 4 equal to 3x here. Now, the answer is a fraction, but that's no big deal. So we have 4/3 would be the answer for the log base 8 of 16. All right, now I'm going to bring some fractions in, so think about negative exponents here. So set this equal to x to get rid of the log. We're going to convert it to an exponential. Base of your log, we're going to push that x up in the air, keep the 32 where it's at. This would become, let's see, 1/2 to the x. All right, what number do we want to use as a base here so I could have the same base on both sides? 2, right? All right, so 32 is 2 to the 5th. That's all I would do there. 1/2 would be 2 to the negative 1. And if I got my bases the same, bases are both 2, that forces those lovely exponents to be equal. So here just 5. And here on the other side, negative 1 times x. So it'd be 5 equals negative x. So then I'd have to get rid of the negative just real quick, divide that. So x would be negative 5 for that question. And then I've got one more. Just set these equal to x. That allows you to get rid of the log by converting it to an exponential. Keep the 1 over 32 where it's at. Now, base of the log, which is 64, we're going to push that x up in the air. That becomes the base of my exponent, so I have 64 to the x. Okay, now we just did 32 is 2 to the 5th, right? If I have 1 over 32, it's just 2 to the negative 5th. And then 64 is 2 to the 6th, but then I'm taking that to the x. So once I get my bases both to be the same as 2 here, we're just going to set our exponents equal to each other. So we'd get negative 5 equals 6 times x. So we would just divide by 6 real quick to get the x alone. And it would be negative 5 6. Is anybody having a question? It's not terrible once you get the hang of it, but these questions you do want to be able to do without a calculator. Feel free to use that little yellow piece of paper if that helps you to think about what bases you might want to use or exponents. And then I'm going to give you guys the rest of the time to work on the assignment here. So please let me know if you have